going to discuss acid-base disturbances and make predictions of a patient's acid-base diagnosis given their arterial blood gas values. So we're going to focus on looking at blood pH, the PCO2 in the plasma, that's the dissolved carbon dioxide in the plasma. And remember that CO2 makes acid, so the more CO2 in the plasma, the higher the PCO2, the more acidic conditions we're going to see in the plasma. And we're going to look at bicarbonate ion. Bicarbonate ion is also in the plasma, and it is a ion that acts as a base, so it soaks up excess acid. And the kidneys control bicarbonate ion, so they can either, as bicarbonate ion enters the tubules from the glomerulus, the kidneys can either reabsorb it back to the blood and increase its value in the plasma, or the kidneys can keep it in the nephron and send it to the urine. So we would see a lower concentration of bicarbonate in the plasma if the kidneys are excreting it. So there's two options there depending on what the needs of the body are. So I've given you here the normal values for pH, bicarbonate ion, PCO2, and PO2 that we would normally get in an arterial blood gas. And also I have some hints here. Remember the PCO2 due to slow breathing will cause acidic conditions because it's building up in the blood, and that would cause pH to go down. So pH, a dropping pH is a sign of acidosis. And bicarbonate ion acts as a base and it helps correct a low pH. It fixes acidic conditions. So again, the kidneys can either reabsorb bicarbonate and send it back to the blood to increase its value, or it can leave bicarbonate ion in the nephron to be excreted in the urine, therefore decreasing that value in the blood. So we're always going to see an increased bicarbonate ion if the kidneys are trying to correct a falling pH, so anything less than 7.35. So a quick hint to remember when we're looking at trying to determine an acidosis and an alkalosis, whether it's metabolic in nature or respiratory in nature, is if the pH and the bicarbonate ion levels are both high, we know it's metabolic. If they're both low, we know it's metabolic. We know it's respiratory, acidosis or alkalosis, if the pH and the PCO2 are opposite of one another. If one is high and one is low, again, we know it's respiratory in nature. So just keep that in mind as we look at these values and try to diagnose. So I recommend looking at this flow chart that I made. I kind of took the information that we use to interpret arterial blood gases and created a flow chart starting at the top and working our way down. So we're always going to start by looking at the pH to determine, do we have an acid situation or an alkalosis situation. Anything greater than 7.45 is alkalosis. Anything less than 7.35 is acidosis. So let's go and look at our data. So if we look at this one, blood pH is higher than 7.45, so I have some type of alkalosis going on here. And if I look at my other values, do we see any others that are greater than 7.45? Here's one. That's another alkalosis. And looking on here, I see another one, another alkalosis here. So just quickly looking over my values, I can see that I have 3 different patients with alkalosis. Now I don't know the cause of those until I analyze the values here. Let's look at the rest. Looks like this one is less than 7.35, so I have an acidosis situation there. And if I look at any others, this one is also less than 7.35, and so is this one. So right away I'm working my way down my flow chart to determine what I have in my patient, whether it be acidosis or alkalosis. This one here is within the normal range, so I can say normal pH. So let's look back at our flow chart. So now we've determined we've got acidosis or alkalosis. Now we have to determine between these two. Is it respiratory? Is it metabolic? Well, we know that CO2 makes acid. So if I see a low PCO2 and a high pH, I know that is going to be due to the respiratory system, because low CO2, remember CO2 makes acid, so if I have low acid due to respirations being too high, then that's going to create an alkalosis. So again, low PCO2, high pH, they're opposites, that indicates a respiratory cause. So if I look here, I have a high pH. Is this a lower than normal value for PCO2? Yes, it is, because the low value for PCO2 should be 35. Here it's 19. So right away, because these two are opposite in nature, I have a respiratory alkalosis. If I look here, I have looking at values, I have a low PCO2 and I have a low pH. So that's not opposite. So that's not respiratory in nature. Only when one is high and one is low, when I'm comparing PCO2 to pH, do I know it's respiratory in nature, because I know that a low PCO2 means low acid, and low acid would cause a high pH. So only when these are opposite in value is it respiratory in nature. So here I have a low PCO2 and a low pH, so I know it's not respiratory. Therefore, if it's not respiratory, it must be metabolic. And I know it's metabolic because I have a low bicarbonate ion and I have a low blood pH. And like I said, if you look at the bottom here, for metabolic, if both the pH and the bicarbonate ion are related in that they're both high or both low, I know I have a metabolic situation going on. Again, when one is high and the other is low, when I'm comparing these two values, I know it's a respiratory. So looking at this one, we have a high PCO2 and we have a high pH. That doesn't match for respiratory because they should be opposite if it's a respiratory cause. So let's look at the bicarbonate. For the bicarbonate ion, I have a high bicarbonate and a high pH. Those are both high, so therefore I know this is another metabolic cause. So it's something outside of the lungs that is causing this problem. Now this one was normal, so we'll skip that one and go on to the next one. So I have a high PCO2 and a low pH. They're opposite one another. We know if they are opposite that that's a respiratory cause. So I have a respiratory acidosis. If I look at the next one, I have a high PCO2 and I have a high pH. Again, that's not opposite, so it must be metabolic. And I can verify that by looking at my HCO3, my bicarbonate ion. My bicarbonate ion here is high and my pH is also high. And we know if both are high or both are low, that's metabolic. So I can go ahead and fill in metabolic. And then the last one here, I have a high PCO2 and I have a low pH. They're opposite. So that makes sense. That would be a respiratory cause. Alright, so I've figured out which ones are respiratory, which ones are metabolic. Now I have to figure, is the other system compensating? So if I have a respiratory alkalosis, are the kidneys compensating by trying to fix the bicarbonate ion to correct the pH? So let's think about how bicarbonate and pH are related again. So if I have a high blood pH, that means I have less hydrogen ion. So therefore, the kidneys, if they compensate, they're going to, if I have a high pH, let's talk about that again. I got ahead of myself. So we have a high pH here. So that means we need to, in order to bring the pH down, the kidneys would want to get rid of bicarbonate ion because bicarbonate ion is a base. Remember, bicarbonate ion helps a falling pH. Here we don't have a falling pH, we have a rising pH, so we don't need to keep bicarbonate ion. We want to get rid of bicarbonate ion. And that's what's happening here. If we look at the normal value for bicarbonate ion, it should be 22. Here it's 19.5. That's a low value, so the kidneys are compensating by getting rid of bicarbonate ion. Let's say it's dumping HCO3 minus. So do we see any other situations where we have renal compensation going on? Where do we see other low values for bicarbonate ion? That's respiratory in nature. So first of all, we have to look for a respiratory problem and see if the kidneys are fixing it. So here's another respiratory problem. Are the kidneys fixing it? So we have a respiratory acidosis due to the high PCO2. Are the kidneys fixing that problem? Well, if I look at my kidneys, I can, or my bicarbonate ion, I can see that it has a value of 25, which is in the normal range. So I would say no renal compensation. Any other ones? Here we have another bicarbonate ion, and here it is, we have a respiratory acidosis, so we have acid conditions, and we have a high bicarbonate ion. So that bicarbonate ion is being retained by the kidneys, sent back to the plasma to soak up the excess acid, which is occurring with this low pH. So we would say yes, we have renal compensation, which is reabsorbing bicarbonate ion. All right, so we look at some kidneys compensating. Now we can see, is there any respiratory compensation with these metabolic problems? So looking at metabolic acidosis, the respiratory system, if we have acidosis, the respiratory system would want to have, if we have acid conditions, the respiratory system would want to get rid of PCO2 in order to bring that pH up. So we would expect to see a low value of PCO2. And if we look here, yes, we do see a low value for PCO2. It should be 35. It's only 30. So we have yes, the respiratory is compensating. And the way it would do that would be rapid, shallow breathing, like we would see in hyperventilation. That causes a low PCO2. So that would be a way that the lungs would be trying to get this pH to raise by getting rid of PCO2, by getting rid of carbon dioxide. So in this one, this metabolic alkalosis, we can look and determine, is the respiratory system compensating? We have a high pH, therefore we want to hang on to carbon dioxide. So we'd want to, if we're hanging on to PCO2, we would see a higher than normal value, and we do here. So therefore, the respiratory system is compensating here, and the reason, or the way that it would compensate would be with slow breathing. So with slow breathing, by hanging on to that carbon dioxide with slow breathing, that should help lower that pH, because remember, it's a metabolic alkalosis. This bicarbonate ion is too high, causing a high pH. So in the next one, we have a low PCO2, but we have a normal pH. So the patient looks otherwise healthy, but if I look at this bicarbonate ion, I see that too is low. So if I have a low bicarbonate ion, that would cause acid conditions. So we're correcting this PCO2 value is low, which would cause the pH to go high. So we have low PCO2, which would cause, again, high values for my blood pH, but it doesn't go very high because my HCO3 is low. Remember that bicarbonate makes base conditions, so if I have a low bicarbonate, that would lower my pH, and that would prevent this PCO2 from making the pH go up. So I actually have renal compensation going on here. Is keeping the pH from rising due to the, rising due to the low PCO2. The next one, this metabolic acidosis, if I look at the cause here, we have a PCO2 that falls within the normal range. So I have a metabolic alkalosis here because I have a high HCO3 and a high pH. So is the respiratory system fixing it? No, it's not. So what might be some causes of these conditions? I think it's important to look at possible causes. I'm going to insert another column here to figure out what possible causes we might have of these conditions. So here I have a respiratory alkalosis. If I go back to my chart, we have a respiratory alkalosis, which means we have a high pH due to the lungs. Going to my chart, a respiratory alkalosis could be due to hyperventilating. So if we have anxiety because of someone just got some bad news, someone is in a lot of pain and they're breathing very shallow and rapidly because they're in a lot of pain, or if they're exhausted, someone who is in the middle of an intense basketball game that's tied and then in overtime, sometimes we see players have to go to the sideline and breathe in a brown paper bag due to exhaustion, or people that are just finishing, say, a cross-country race. Those are all reasons for a respiratory alkalosis. So we'll just say hyperventilating. Number of causes. So here's a metabolic acidosis. What could cause a metabolic acidosis? Well, metabolic acidosis could be from, if we go on this side, here's the acidosis. Metabolic causes of that could be diarrhea. If we lose bicarbonate ion, that could cause a metabolic acidosis. If a person has diabetic ketoacidosis, their body is breaking down fat and protein for energy. That creates keto acids and builds up acidic conditions in the blood. Or excessive exercise or seizures because of the buildup of lactic acid. So those are all possible causes of a metabolic acidosis. So if we look back at our chart, do we have any information here? Well, here we have a low bicarbonate ion, so that could be due to diarrhea. We'll just put that one down as a possible cause. Oh, I'm bad at spelling that. So looking at metabolic alkalosis, so we have a respiratory compensation, we have a high bicarbonate ion. What are some causes of a metabolic alkalosis? Going back to our chart, metabolic alkalosis, we could have prolonged vomiting. If we're losing a lot of hydrogen ion, that could cause a metabolic alkalosis, or if a person takes too many antacids, that too could cause a metabolic alkalosis. So a number of different causes here, it's hard to know. So let's just put vomiting or antacids. So here we have normal pH, but we have the lungs are compensating due to that low bicarbonate ion. So what would cause a low bicarbonate ion? It's hard to say. It could be, again, due to a diarrhea, because we lose bicarbonate ion through the digestive tract with diarrhea. That could be a cause. Here we have a respiratory acidosis. What would cause respiratory acidosis? Well, we're building up carbon dioxide, creating acid conditions. So anytime we have low respirations or poor diffusion of carbon dioxide out of the alveoli, we're going to have a respiratory acidosis. So when someone is not breathing well due to pain medication, alcohol, drugs, or emphysema, we end up with a respiratory acidosis. So anything that's going to cause low respirations and not blowing off that CO2. Or poor gas exchange is going to cause a respiratory acidosis. So we already talked about a metabolic alkalosis, and we already talked about respiratory acidosis. So whenever we see compensation like this is very common in emphysema. When we see poor gas exchange occurring across the respiratory membrane, but we see the bicarbonate ion and usually high, that's classic for someone with emphysema because their kidneys are taking care of the situation. When we see no compensation, that's usually a short-term cause. It's something that's happening just, at that time, because it takes a while for the kidneys to kick in and increase the bicarbonate ion levels in the blood. So people with long-term emphysema, we're going to expect to see a higher bicarbonate value, and that would be normal for them. But in some of these where there is no compensation, it might just be because it's a sudden situation and the kidneys haven't had time to kick in, or they might have kidney damage, so it's hard to know. And if you look at the case studies that you're given for acid base, you do have extra information to give you some clues as to what might be the causes of the different diagnoses of acid base imbalance. So I'd like you to take this information now, work with the chart, try to make multiple copies, try to predict what you think is going on, and really practice with this. And the case study assignment that I was given out with this lab. I'm not going to go over the answers for because I do want to include some of those questions in a very similar format on your exam on the renal system. So I want you to work through those on your own. You do need to fill them out. I will take points on them in lab for your next lab exam because you need to have them done before the next lab exam. But I'm not going to go over the specific answers. I'd like you to work through them on your own, ask questions, but I'm not going to correct them. I want you to work through them on your own. So any questions, you can always email me or stop by before or after class.